Here we have the matrix representation theorem. It says that if we have two vector space V and W, we have two ordered base E for V and F for W, and we have a linear map L from V to W. Then we can find the representative matrix A of L as follows. We find the columns. So the jth column of L is the vector or the image of the vector Vj, where Vj is the jth vector in the ordered basis of E. Right, so we compute the image of V1, put it in the column 1, compute the image of V2, put it in column 2, and we can have n such columns, and we have n column vectors, and that will give us the matrix representing F relative to the ordered base E and F. So two things important: the basis E and the basis F is ordered, so the order matters. And yes, we just need to compute the image of the basis of vectors in the basis of E and put it and write it as the coordinate in term or with respect to the basis F, because the image of Vi or image of Vj will be a vector in the vector space W, and F is a basis for W, so we can compute the coordinate of this vector relative or with respect to this basis. And here is an example. P3 is a vector space of degree 2, at most 2 polynomials, and E is an ordered basis of P3. So E is a basis with 3 vectors, x squared, x, and 1. Similarly, we can have P2 is a vector space of all polynomial of degree at most 1. Right. And F is an ordered basis of P2. Now let D be the linear map from P3 to P2 given by the formula. D of P is a derivative of P. So this P is a polynomial. So it's just compute the derivative of P. For example, you know the derivative dx of, say, x squared. This is 2 times x. Yeah. And we need to find the matrix representative of the linear map. So from the theorem, we just know we just need to compute the image of the vectors in the basis E, and then compute its coordinate with respect to F, the basis of the codomain, right? So 3 vectors in the basis E of P3. So 3 vectors is x squared, x, and 1. We compute the derivative of x squared, we have 2 times x. 2 times x in the coordinate of 2x with respect to F. So F is the basis or basis contain 2 vectors x and 1, right? So we can find the coordinate of 2x by 2 times x plus 0 times 1. So the coordinate of x dx squared with respect to F is 2, 0. Similarly, we can compute the derivative of x equal to 1 and compute the coordinate of 1 with respect to F, which is 0, 1. Compute the derivative of the last vector in the basis E. The derivative of 1 is 0. The coordinate of 0 with respect to F is 0, 0. Now we put the first coordinate to the first column, second coordinate to the second column, last coordinate to the last column. We have the matrix A, the matrix representative of the linear map F. And now we have the derivative of this, derivative of any polynomial in P3. Say ax squared plus bx plus c will be a times the coordinate, right? So a times the coordinate of this polynomial, right? The polynomial ax squared plus bx plus c is in with respect to e is a b c. So a times a b c is this matrix a times the coordinate, which gives us the coordinate of the derivative 2ax plus b times 1, 2x plus b.